Assalamu alaikum everyone. Here is Sir Usman Ghani with the third topic, that is HCF, highest common factor. For example, we have a question, find HCF of 210 and 350. So you have to do it with two methods. It's up to you. It's your own choice which method you would like to use, but I want to explain both methods to you. Here you can see that the first method, that is prime factorization. Here you will write 210 in one table and 350 in another table. You have to do prime factorization. First of all, the smallest prime number 2. It can divide both numbers because here it is 0 in the end. Whenever there is 0 in the end, you can divide it with the table of 2. So 2 ones are 2. And now the next number, that is 1. 1 is smaller than 2. Therefore, you have to use two numbers altogether. When you want to use two numbers, you have to place 1 0 here. Remember again, it's very important. 2 ones are 2. 1 is smaller than 2. Therefore, we will take two numbers altogether and we will place 1 0 here. Whenever you take two numbers all together, you will write 1 0. Now, two fives are 10. Now, the next number, here you cannot divide 105 with 2 because the last number is 5. The last number is not an even number. It's not among 2, 4, 6, 8 or 0. Therefore, you cannot divide it with 2. Now you have to check another number. You can divide it by 3. For dividing it by 3, you must count the numbers. 1 plus 5, it's 6. So 6 is the friend number of 105, and 6 can be divided by 3. Therefore 105, its friend number, can also be divided by 3. So here in 3 table, 3 threes are 9. We want to make 10, but here we have got 9. 3 threes are 9. We have left 1. The remaining 1 will be considered here and it will become 1 5 15. In table of 3, we can divide 15 like 3 fives are 15. Now, this number is now 35. Add up the numbers. 3 plus 5, it's 8. It cannot come in 3 table. Therefore, 35 cannot be divisible by 8. Now you can see that the last number is 5. Therefore, it will be divided by 5. 5 sevens are 35 and then 7 ones are 7. Now the next number we have 350. Here you can see that 0 is at the end. Therefore, in the table of 2, so 2 ones are 2. Out of 3, we have got 2. We have 1 left. It will be considered here. And now 15, in 2 table near to 15, 2 sevens are 14. And 1 will be considered to the next one. Because we have not made 15, we have made 14. So remaining 1 will be considered with the next number. It will become 10. 2 fives are 10. Now for checking that whether it is divisible by 3 or not, you will add up the numbers. 7 plus 1, 8 plus 5, 13. So it is not divisible by 3 because the sum of number is not giving the number which is divisible by 3. So now for the next number, we will see the number 5. In 5 table near to 17, 5 threes are 15 and the remainder will be 2. It will be considered here. It will become 25. It will become 25 and in 5 table 5 fives are 25. Now we have got again 35, the same like here. You will use 5 table, 5 sevens are 35 and 7 ones are 7. Now you can see that 210 equals 2 multiply by 3 multiply by 5 multiply by 7, and 350 equals 2 multiply by 5 multiply by 5 multiply by 7. So 2 multiply by 5 multiply by 5 multiply by 7. Now HCF will be the common. 2 is in both, so 2 will be written here. 3 is not common, 5 is common, and the next 5 is here but not here. It is being used. Now 7. Now boys, you can see that 2 5s are 10, 10 7s are 70. So the HCF is 70. Now with the common division method, we can write 210 and 350 all together in a single table. Here you can see that in 2 table, 2 ones are 2. Again we will see the both two numbers together, so we will place 0. 2 5s are 10, and in 2 table 2 ones are 2, 2 5s are 2 7s are 14, and 2 5s are 10. Now any number which can divide both the numbers, 3 can divide 105, but 7 plus 1 8 plus 5 13. 3 cannot divide 175. For common division, both the numbers or all the numbers must be divisible by the same number. Therefore, we cannot divide it by 3, because 3 can divide this number but not this number. So we will have to check the next prime number, that is 5. 5 2s are 10, and 5 1s are 5. Now in 5 table, 5 3s are 15. Out of 17 we have got 15. 2 will be the remainder, it will be considered with the next, so it will become 25. 5 5s are 25. Now any number which can divide both the numbers, that is 7, because 3 can divide this number but 3 cannot divide this number. 5 can divide 35 but 5 cannot divide 21. So we have to check the number which can divide both the numbers. So in 7 table, 7 3s are 21 and 7 5s are 35. Here you can see that 3 and 5, they both are the prime number. Whenever you get prime number here, you will have to stop the process. Why? Because 3 and 5 cannot be divisible in any other number. So stop the process. And HCF equals 2 multiply by 5 and multiply by 7, and you get 2 5s are 10, 10 7s are 70. So you get the same answer by both methods. Again, I want to tell you about the common division method. You have to write both the numbers in the same table, and the other thing is you have to divide both the numbers by the same number. We have selected 2 because 2 can divide both the numbers. We have selected 5 because 5 can divide both the numbers. We haven't selected number 3 because 3 can divide this number but 3 cannot divide this number. So we have to check 5. And then in 7 table, 7 can divide both the numbers. And when we cannot divide both the numbers by the same table, there is no table which can divide 3 and 5 together. Therefore, we stop the process, and HCF is 2 5s are 10, 10 7s are 70. So this is it. It's very easy, and I hope you have understood the concept.